Okay, so I've already gotten a couple of emails from all of you guys about talking about how some of this stuff is new and we're kind of struggling. I really appreciate that you guys have already started emailing me and getting on top of this. Right? I love that you guys are trying things out. Right? This is new for you and this is new for me, but we're gonna get through this together. So this week we will talk about inverse functions. Some of you maybe you don't remember what functions are. And functions are things that we've kind of been through for a lot of our math careers. So if we look over here, this is a function. But we've seen something like this before. This is just an equation, right? Y is equal to 2x plus 4, that's nothing. Right? You just put in a number for x, a number for y pops out. Well, we've kind of introduced this new notation, right? This f of x. It represents the exact same thing. It's still the y value. It's just kind of new notation and a little bit more detailed. But it behaves the same way that you've been used to. For example, let's say we substitute in -2 for x. So let's look over here. There's a -2 over here. What happens if I substitute that in for x? Well, -2 times 2 is -4, and -4 plus 4 is 0. Okay, maybe let's try out -1. Oops. Trying to be color coding kind of guy. -1. If I substitute in -1 for x, that's 2 times -1, which is -2. -2 plus 4 is 2. We've done this before, right? This is something that you've probably done for a while. So this is nothing too unfamiliar. Let's say we wanted to graph it, okay? Well, we've done that before too. So let's say, let me pick a color, all right? This point right here is 0, 4, and this point right here is 1, 2. Where did we get those points? It came directly from our table. Right? We've done stuff like this before. Now sometimes we want to talk about the inverse of a function. So I really recommend for you to pause the video and compare these tables. Okay, I'm going to tell you that this table right here and this graph right here represents the inverse of our function above, right here. Right? The table and graph below represent the inverse of the function above. So I ask you to pause the video. What do you notice about the two tables and the two graphs? What are some things that you notice? Take your time, pause the video, think it through. So hopefully you guys have taken your time to think through the problem. Maybe some of you guys noticed. The x and y values, they're backwards. Okay? For me to maintain a color coding kind of guy, to be a color coding kind of guy, now instead of -2, 0, now it's 0, -2. Ooh, they've changed places. Okay, instead of -1, 2, now it's 2, -1. That's what it means to be the inverse of a function. The inverse of a function swaps the x and y values. Up here, it was -2 and 0, -1 and 2. Down here, they've flipped. 0 and -2, 2 and -1. That's what it means to be the inverse of a function. The x and y values have been flipped. But let's look down here. Let's look down here for our graph. This, well, we can still get the same kind of graph with this table, right? This point over here is 0, -2. And this point over here is 8, 2. We get that directly from our table, right there. Still same kind of deal. Well, what did you guys notice about the relationship between this graph right here, and the graph up there? Alright, I'm going to move this right here. Maybe you guys will see. Okay. Let me just erase some of these points real quick. What's true about inverse functions, at least in terms of the graph, is, well, the x and y values are still flipped, but the really cool thing, let me actually pop out a ruler. The really cool thing is that they've actually been reflected. So let me pick a color. When you graph the original function and the inverse of a function, they look really, really similar, right? It's just reflected across this green dotted line. And that's really, really cool. But what if you actually wanted an equation, right? Tables and graphs are great, but sometimes equations are better. I don't know about better, but it's just nice to have, okay? Well, we have a way of doing that, and it comes right down here. So this green text right here is from the Paul's online notes. It's in the Google Doc that I shared with you guys on Schoology. Definitely click the link. It's definitely tough. I will definitely agree with you. Reading math is hard, but if you come with questions, I'm always willing to make a video. So let's go through it. Let's say we had a random function, any random function. Let's say f of x is equal to 3x minus 2, right there. I want to find f inverse of x. By the way, if you guys aren't familiar with the notation, this -1 up here, that represents f inverse, the inverse of x. I want to find the equation of f inverse of x. Well, this step-by-step process is going to help us out. First step, replace f of x with y. And honestly, I'm sure a lot of you guys want to do that anyways, because this is really funky notation. So let's just switch it back to what we've been used to. Y is equal to 3x minus 2. Next step, replace every x with a y. So let's once again be a color coding kind of guy. Well, so x values are yellow and green and y values are green. Okay. So this x and this y, they swap places. Okay. Now this y became an x and this x became a y. We have successfully done step 2. We've replaced every x with a y and replaced every y with an x. Step 3. Solve the equation for step 2 from step 2 for y. This is the step where mistakes are most often made, so be careful with this step. And it's true. Solving equations is hard, but we can do this. I believe in all of you. So, let's solve. First step. If you wanted to get y by itself, if you wanted to solve for y, well, we can add 2 to both sides. Oops. Add 2 to both sides. That cancels out the 2's. Now we have x plus 2 is equal to 3y. Well, we can divide both sides by 3. Oops. Divide both sides by 3. And lo and behold, y is all by itself. Y is equal to x plus 2 over 3. Last step, very, very last step. Replace y with f inverse of x. In other words, we've managed to find the inverse. And it's right there. That's how you find the equation of the inverse of a function. Okay, so if you guys have any more questions, please shoot me or Mr. Peck an email. I'd love to keep making videos.